Okay, guys, onto the back side. So I know this is an awful sheet. When I was printing it off, things got mixed up. In class, I've told people about writing these down. Um, if you get stuck, it doesn't mean you're going to do poorly on the quiz. The quiz does not have these issues. And I'll be there to talk you through anything that seems weird. And frankly, some of these questions here are harder than on the quiz. So I just wanted to make sure that you're fully aware of everything before we just take the quiz and then move on and don't think about integers again the rest of the year. So my intent here is to say 19 and 20 to put those up over here, just like we did in the class practice. So for 19, it's the x-axis and 20 will be the y. So 19 is negative 4 and 2. So I'll come over here and I'll go over negative 4 and then up 2. So that's the first. And so what I want to do is reread it. It says reflected in the x-axis. That means the x-axis is like the mirror. It's like the lake. So I'm going to stay on negative 4, but now I'm going to be down 2. And what I do is I look over and say if this is up 2, well, this would be the same, but down 2. Okay, that's 19. And now 20 would be negative 5 and negative 3. But this one is reflected on the y-axis, so this is like that mirror. And if you think about a mirror, things that are close, you'd reflect right next to it. But far away, the reflection is further away. The height doesn't change, though, in a mirror. So if this is negative 5, this will stay on this line and be all the way over it. Positive 5. And there we are. We've just reflected these two things. And there really are, if you notice, it's just like opposites. Like this is the opposite of this. And this is the opposite of that. And that's what reflections are. 23. A number is less than 15 and more than negative 2. So I could draw a crude number line and say, so I've got a 0, I've got a negative 2, and I've got a 15. And it's saying less than, which means not 15, but everything else can be here. Okay. So what is the least possible integer value of this number? So can it be negative 2? No, because it says more than negative 2. Could it be negative 1.99999? No, because it says integer. So what's the next integer above negative 2? Negative 1. That's the least possible integer. The greatest possible integer, can I do 15? No, because it says less than 15. If it said a number is less than or equal to, then we could, but we can't. So what's just under 15? 14. Keep in mind the big question there is integer, or the big keyword is. Okay, so the change in prices. So I've got the table shows the change in a stock price over a 5-day period. So on what day did the stock price increase the most? That means the highest positive number. That'd be right here, day 2. And then on what day did the stock price decrease the most? So that'd be the biggest the smallest negative number, the furthest away from 0. So as I look, negative, negative, and even though this just has the one digit, keep in mind it's 3 holes, negative 3 holes. These are things that are barely between negative 1 and 0. So that would be day 5. And then the most change, well, that still happens to be day 5. So whether it's positive or negative, moving the most, that's the biggest one. Saturday, you spent $10.75 at the pharmacy. You earned $5.50 for yard work. You should be thinking spent and you should be thinking earned. Using a negative number for money spent and a positive number for money earned, represent each value as a positive or negative number. Man, this is actually like really easy just because they even tell you like this must mean negative 1075. Oh, wrong one. Negative 1075, positive 550. And which one is closer to 0? It would be this one because it's only 5.5 away from 0. I don't know. That seems like a lot of talking for nothing. So in class, I had you write these down. Okay, A, I had to say, like, try to complete the rectangle. So A, 4, negative 1, over 4, down 1, right there. B, negative 1, down 1, right there. And I should label it too. A, B. C, negative 1, up 5. Oh. Wow, that's pretty, okay. And so where is D? Well, look, I mean, it's going to be up here, right? Like, complete the rectangle. I don't know. I don't know what else to say. We talked about like use the clues. If it says rectangle, do that. Don't overthink it. So D, I should figure out that's 4, 5. So I might then say, so D is 4, 5. Actually, I should have done that here. D is 4, 5. B, find the perimeter. So what I'll do is I'll just count some of the sides. If it's a rectangle, I don't actually need to count them all. I could just count this side and this side because I know that this would match this one and this would match this one. So over here it's 1, 2, 3, 4, 5. And then I'll just keep counting. I'll go 6, 7, 8, 9, 10, 11. Maybe I'll just say 5 and 6, right? But that's 11, so 2 of those. Double 11, you're going to get 22 units. That's the perimeter, the distance around the outside. The area is taking the 2 different length and width sides, so like ones that are adjacent basically, side by side, and multiplying them. If I count it up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I would get 30 squares in the center. The shortcut in math is to just say length times width, 5 times 6, it would be 30. For people trying to be really high speed too, we would say 830 units squared, or square units, because that's just the fancy word. I mean, notice we counted the squares, so that's really where that exponent of 2 comes from, okay? Hopefully that helps people out. Like I said, the quiz tomorrow is going to be way simpler. Some of these questions here, I feel like the most complicated ones are not going to be on the quiz, but I still want you to be thinking about them. And if you watch the video, they should be pretty easy to get down on paper. Thanks.